All right, let's see if I can get this in under 5. So we have our function. We're going to factor this thing. So the first thing we can do is pull a 2 out of the numerator to get a 2x squared plus 5x plus 6. And we can factor that in a second. All right, so this numerator is going to factor into 2, x plus 3, x plus 2. The denominator is going to factor into x plus 2, x plus 1. So we can find our domain at this point. The domain is where the denominator is equal to 0. The denominator is equal to 0 when x plus 2 is equal to 0. X is negative 2. Or where x plus 1 is equal to 0, x is negative 1. So our domain is going to be all real numbers except negative 1, negative 2. All right, so then we do have some cancellations here. In this case, we have a cancellation with this x plus 2. Those cancel. So that means we're going to get a whole at negative 2. So negative 2 something is going to be the whole. Our most simplified version is 2 x plus 3 over x plus 1. All right, so let's figure out what the whole is. So to do that, we're going to plug in negative 2 for x in our simplified version. 2 times negative 2 plus 3 over negative 2 plus 1. All right, so it's going to be 2 times 1, 2, negative 2 plus 1 is negative 1, so we're going to get negative 2. Negative 2, negative 1 is our whole. So let's get that in before we forget it. Negative 2, negative 1, whole right there. All right, so that takes care of this part of the domain. So x equals negative 2. That is going to be our, whoa, let me try that again. So this takes care of that part of the domain. X equals negative 1. This is the other, is going to be the vertical asymptote. So we're going to have a vertical asymptote at negative 1. All right, so then now let's figure out our x-intercepts where the numerator is equal to 0. So if we have in this simplified function 2x plus 3 over x plus 1, the denominator equals 0 when x plus 3 is equal to 0, or x equals negative 3. So negative 3, 0 is our only x-intercept. Our y-intercept is going to occur when we plug in 0 into any of the functions. Alternatively, remember, we could just take the ratio of the coefficients. So it should be 12 divided by 2, 0, 6, but let's plug in and see what we get anyway. So 2, 0 plus 3 over 0 plus 1, that's 6 over 1. Like magic, it's exactly what we thought it was going to be. So we have 1, 2, 3, 4, 5, 6. We're going to have our y-intercept there. And then let's figure out a horizontal asymptote. So the degree of the top is 2. The degree of the bottom is also 2. So that means the degrees are the same. Whenever the degrees of the top and bottom are the same, it's going to be the ratio of these coefficients, 2 divided by 1. So 2 is going to be our horizontal asymptote. Y is equal to 2. It's a much better straight line than I drew in the last video. I jinxed it. Y is equal to 2. And then, although we can know what this function is going to do at this part, just using kind of like the logic of last video, if we have negative 3, our asymptote, which is negative 1, and, well, that's it. If we plug any value less than negative 3 into our simplified version, like negative 4, remember our simplified version 2, x plus 3, x plus 1, we don't care about this 2, it's positive, doesn't affect anything. Negative 4 plus 3 is negative. Negative 4 plus 1 is also negative, so it's going to be positive on this interval. If you plug in anything between negative 3 and negative 2, although we know it's going to be negative because of the whole, we would plug in, if you plug in, say, negative 2, you're going to get negative 2 plus 3, which is positive. Negative 2 plus 1 is negative, so negative on that interval. Again, we know what's going to happen. We know that the between negative 1, I just completely lost what I was going to say. I'm out of it. So if we plug in some value between 1 and infinity, we know what it's going to be because we have the y-intercept. We know the y-intercept is positive. But if you plugged in some value like 1, we're going to get positive and positive. right, so that means that our function has to do something like this. From negative infinity to negative 3, it has to be positive. It has to hit that y-intercept. Then from negative 3 to 1, it has to be negative. It has to pass through that hole and go down here. I missed 5 minutes. And then from negative 1 to infinity, it has to be positive, hit that y-intercept, and go off towards that horizontal asymptote. So something like that. If you have any questions, do not hesitate to shoot me an email or a text, or shoot out a pigeon with a note on its leg, whatever. Just ask questions. Good luck.